3D printing electronics has evolved dramatically over the years, and I'm going to talk with Martin Hedges. He's the founder and CEO of Neotech AMT, based in Germany, and also one of the partners of the 3D Printing Electronics Conference. And I would like to know more about his view on what's happening and what's going on. So, Martin, welcome at this interview. Can you give a short introduction of Neotech, your company?
Yes, of course. So good afternoon. So Neotech AMT GmbH, we're based in Nuremberg, Germany. We are a machine tool manufacturer specialized in 3D print electronics. So basically that is all that we do. So this interview is a subject very close to my heart. We've been around for a number of years. We started our first developments in this field back in 2009. We built our first systems in 2010, obviously very experimental in those days. And we actually, moved to designing and building the first production level system in 2012. And that has seen some action in Asia, in cell phone manufacture. And since 2016, we've also been combining sort of printing electronics, traditionally on outside surfaces of the existing components, with classical additive manufacturing, 3D printing, so building mechanical structure and then putting electronics inside as well as outside. So we have a couple of different strands that we're working on. The markets are moving at different speeds slightly. There's some overlap, but I have to say it's very good that we're actually seeing a big increase now in interest.
Okay. So it means that in the past it was very academic, but I understand that it's really now be taking off in manufacturing as well.
Yes, so we had one production level application, so printing in the cell phone field onto cell phone housings. In terms of cell phone production, it was quite small, but the customer there was using 4 machines to produce over 2 million parts per year. So for us, it was a fairly sizable step forward. So that's given us a good benchmark to work from.
Okay, so. And you said you're also combining now, let's say, traditional additive manufacturing. And are you doing this in one machine, or is it additional machines, or how are you dealing with that?
So basically, at the moment, we have systems that combine all of the processes. So what you can do is you work in a modular way. You choose the tools that you want to complete your process. So if I go back to the original work we did on cell phones, you start with injection molding, so you have a physical structure, and then you have your print tools set up and maybe inline sintering tools, so curing sintering tools depending on what you're printing. So that can be light, laser, UV light with UV curable materials. So you array those tools inside the systems, and you can multiplex those, print multiple parts at one time to speed the throughput. And obviously reduce the costs of production. But then what you can also do, as I said, this is something that's really come to the fore since about 2016. Is now really starting to hot up, is combining with classical 3D printing. So we're currently using the fused filament fabrication process, either with filament or with pellet extruders. So you're actually building mechanical structure and then putting your electronics inside and outside, also combined with adding surface mount devices, so you can build complete mechatronic systems like that.
Okay, so it means even let's say sort of you can get rid of the traditional printed circuit board, because you can create the printed circuit board in 3 dimensions, sort of.
Yeah, so the idea is obviously that your mechanical structure is your circuit board. So you're in the very simplest sense, you're using the mechanical structure as your PCB. Now, obviously, to say we're not going to get rid of all PCBs, that's not realistic. But there's certain niche applications where this ability to move in the 3rd dimension gives you some benefit. So in terms of reducing the package size, you haven't got that PCB. You can actually reduce the number of processing steps that you have, and you can also do other things that is simplify the the recycling of parts, because you have less bound together metals and materials, polymers and resins. You're getting rid of that PCB architecture.
Okay, I didn't realize that. That's also very interesting. So what is there? The 3D printing electronics market is still, let's say, compared to the total market, relatively small. So what is important to get 3D printing electronics accepted in the market?
Well, I think the a couple of things need to happen. Obviously, we need to work very hard on maturing the technologies. You know, we're quite well advanced in combining and integrating these individual steps. What we also need to do now is for example, we're working on sort of AI-driven quality assurance, so inline process monitoring, and then basically having a smart system that will decide whether the parts are acceptable or not acceptable, and then take appropriate action on that. I think we also need to speed up the processes. You know? So we need to obviously be able to do that, to get high throughput out of a single system or a series of systems, to reduce the cost. So I think that is really going to be one thing, is getting to a lower cost base will give us a wider range of applications. So I think that's, you know, that's a point that really does need addressing, that we're working on at the moment.
Okay. Well, I think you've given in a very short time a good overview of where you come from, where you came from, and where you're heading for. So I look forward to listen to your presentation at the 3D Printing Electronics Conference, January 21st next year. So thank you very much, Martin. Have a nice Christmas and New Year.
Okay, thank you very much, Peter.